So today we're going to talk about inverses. So on the top of your page there are some examples of inverses. So the first thing, if you're looking at the table, this first table is just f of x. And the second table is the inverse of f of x, and this is how you write it. So you write the f, then you put a little -1 like an exponent, and then the x. So if you compare the two tables, hopefully you'll see that all that happened to make it inverse is that we just flip-flopped the two rows. So we didn't change the numbers at all. All we did is just flip-flop the x and the y. And so this concept will play out in everything. So if we look over here at the graphs, if you would pick any ordered pair on the graph, like say right there, that ordered pair is -2, 6. And so if we would stay with the concept that all you do is flip-flop the x and the y, then the order pair that would be on the inverse is 6, -2. So if I plot that, sure enough, there it is, 6, -2. So we could try it with another one. So like that one. That is 0, 4. And so 4, 0 should be on there, and sure enough, there it is. And you do that with every single order pair. So now when we're looking at the equations, you can probably tell when you're looking at this g of x function that all it is x plus 6 and the inverse is x minus 6. So they're not always as easy as that. So I'm going to show you down below that all you do with these ones is you switch the x and the y. Now you have to keep in mind that that g of x is the same thing as y equals. So all you do is you switch the x and the y, so be x equals y plus 6, and then solve it for y, so subtract 6, and there's your x minus 6, that's where it comes from. And so you could do it with the h of x, you could do it with the k of x, and you would get the inverse if you switch the x and y and you solved it. So the main idea is that the inverse, so f -1x, you need to be able to recognize that notation is when you switch the x and y in a function. So now, some examples, write the order pairs of the inverse. So if I gave you this on a test, all you'd have to do is take the y column and put it into the x column, and take the x column and put it into the y column. So that's all I'm going to do, and then you're done. So now number 2 says, what is the inverse of f of x equals x minus 3? So again, if that confuses you, just change it to a y equals. And now what I'm going to do is I'm just going to flip-flop the y and the x. So now it's x equals y minus 3. And I solve it for y. So I add over 3. And so y equals x plus 3. And I can put the little -1 up there. That's what the inverse is. So number 3 says find f -1x of that function. And so you need to be able to recognize that's asking for the inverse. So I'm going to just switch the x and the y again. So it's going to be x equals 1/2 y plus 7. Notice the 1/2 does not come with the x. So I'm going to solve this by subtracting 7 first. So now I'm going to go over here, x minus 7 equals 1/2 y. Now to get rid of a fraction, what you want to do is multiply by the reciprocal. So what the reciprocal is, it's the fraction flipped over. So if it was 1/2, I'm going to multiply by 2/1 on both sides. So that's going to get rid of the 1/2 on the left-hand side. And then I need to distribute the 2/1 to both things on the left-hand side. So 2/1 times x is 2x, and 2/1 times 7 is 14. So the inverse is 2x minus 14. So nice problems would be like number 4, is this the inverse of f of x? And so you can either start by finding the inverse of the inverse, or just finding the inverse of the original f of x. So it's completely up to you. So what I'm going to do is I'm going to just take these two functions and switch the x and the y. And so I would have x equals y plus 2 over 3. So since there's a fraction, what I suggest you do is put the x over 1, and we're going to cross multiply. So when I do it this direction, I get 3x, and when I do it this direction, I get y plus 2. Now to finish solving this for y, I subtract over 2 on both sides. So y equals 3x minus 2. So the answer to this question is yes, because what I just solved for is what they gave me. So yes, they are inverses. You could have taken the actual inverse, so I could have taken this, and I could have switched the x and y in that. And if I would solve that, I would get back the original function. So x plus 2 over 3, which is what they gave us. So either way would be proof that it works. The last thing I may ask you to do is to sketch a graph of the inverse of the function. So what I suggest you do is that you pick some key ordered pairs on the thing. So like 0, 0, I'm going to make myself a table. So 0, 0. I'll choose, how about this one, negative 2, 2. And I'll choose one more over here, negative 3, 6. And I'll choose a few over here, so 2, 2. And another one, 3, 6. So I make myself a table. Now I'm going to make myself another table of the inverse. So I'm just going to recopy. I'm going to flip-flop these two columns. And I'm going to replot these points. So 0, 0 will go here. 2, negative 2 here. 6, negative 3. And hopefully you should see a U forming. 2, 2. And 6, 3. So you'll see it's a sideways U. All an inverse is it's reflected over the line y equals x. So back in geometry you probably learned it's reflected over that line.